Welcome back. We're on to stage 2 now of our game applet. And after we've loaded our resources in stage 1, now we're going to go to our second step, and that's the user controls. Our little chick is going to be a class, and we're going to have a stage 2 as a tester. In the actual game, we'll call an instance of the chick, and the chick will just be passive and the control will be actually part of the game. So stage 2, the tester that we have will have some stuff that will be in the game itself, namely I'm going to make a cloud in it, and I'm going to make the controls listening to the keys and telling the chick what to do based upon the key. So you can see all of this stuff here at the simple game, the source codes here at the wiki, and I'll have the links down below. But all I've done here is I went over to stage 2, and I've selected all of this and copied this part here, and I've pasted it into a new class by pressing new class. And I've also done the same with stage 2. This is the tester class for our chick, and for seeing whether or not the chick moves the way we think according to the keys. So let's take a look at what's going on. So here in stage 2, this is the tester class. I've added an instance of the chick, and I'm going to be showing the screen some messages. And then, of course, I also want to show the last key type in case there's a problem, and I want to see what's going on. And then this next part has to do with double buffering. It turns out on most Windows machines, there isn't double buffering, and that means you're going to get a flicker. So you could leave this out if you only worry about people running a Mac. But let's be realistic. So in order to help our Windows users, we have double buffering. And so that requires us to have an off-screen image. And in order to draw things on it, we need the graphics object to manipulate that image. We also have this this rectangle. This is going to be the bounding box of our cloud, and we really actually don't want to test the cloud yet. That's stage 3. But in stage 2, we want to be able to see whether or not the chick can compare its location with the location of something else. So I've just added this little cloud box to represent what would be later an enemy. The load sources we see before. This is what you had in stage 1. But let's take a closer look at our init. Let me make that a little bit bigger here. Okay. So we're going to load the resources in line 39. And we're going to put our message up here so we can see what's going on. In fact, maybe I should run this just so that you can see what we're talking about. If you don't want to open it up every time, this is actually a good tip for Eclipse. Let me show you that real quick. If you were to go here to stage 2 and go to properties, there's run debug settings for stage 2, and if you edit that and change the parameters, for instance, our width is 800 and our height is 600. Press some OKs. Now every time we launch it, it'll remember to set the size so it looks good, and you don't have to waste time stretching it out. But you can sort of see that I want to show what to doing. We're going to use the letter H to simulate a hit. So when I press H, hopefully you hear a little bit of splashing. Also, too, here's the left and the right, the jumping, and you could sort of see, if we look up here, what's going on when I press right or up with the arrow key, or if I go left or right with the letter keys or the space bar. So you'll notice there's a key code, 32 for the space for up. Also 38, that's the up arrow code. That also controls up. And of course, for testing purposes, it's nice to know the X and Y coordinates of the chick. And then we have some Boolean variables that will be helpful for later. Whether or not it's jumping. So I'm jumping now, and it should turn off and fall down to the ground. And also whether or not it's touching the cloud. And of course, to make the game more challenging, whether or not the clouds below you will count whether or not you hit the cloud or the cloud hits you. So I made that little change. You can always make adaptations to your game too to make it more challenging after you play it a while. Alright, so let's take a look at a code, and if you're not interested in the code, you can just go ahead and skip to the next stage if you just want to get the whole thing going. But I'm going to explain what's going on in greater detail. So, the last key then, that holds the string of the last box, and here is our simulated cloud. That's going to be a different class later. Then we have to make the instance of the chick, and the chick, of course, needs to have its image, which we've preloaded, and its location. So I put it in the center, so the right minus left minus the width of the chick. And then, of course, the bottom, that's the stage. Now this is kind of set up so later on I can maybe make levels, and I can have the chick jump on a platform or something like that. I'm not sure, but right now the bottom stays where it is. And of course, now how does the keys? We have to have our game, or in this case our tester class stage 2, be able to track the actions of the keyboard, and so we have to add a key listener. And when we add a key listener, as we did here, it actually changes this. It's implementing an interface called key listener. And if you'll notice, let me scroll down here. In Eclipse, it shows this as an open triangle, meaning that we're actually implementing something from an interface. You've probably seen these green triangles. That means you're replacing or updating, overwriting, if you will, the code from the superclass. So this is an applet, and so it's a subclass of applet, and it has a default update method, and because we're replacing it, it puts a little green arrow. But let's take a look. These three things, the key typed, let's scroll up a bit here. We don't want to do anything when anything types a key. Instead, it's when you press the key down that we want to do something. So the key event E, we can get the code of the key pressed and then test it. A lot of people ask me, how do you know which key is which? And I don't. Fortunately, the key event class has some constants. VK, I'm not sure if it stands for virtual keyboard or not. Maybe, I don't know, viral keyboard? Virtual seems more likely. Anyway, if you do the virtual key left and up, the letter keys, these are all things that are predefined, and so the codes I'm printing, but in a sense I don't have to know what that integer is. But we want to be able to control the chick by these keys, and so the chick class is going to have a method to set the change of x. I call it dx for delta x, change in x. And going to the left would be a negative value, and going to the right is a positive value. And then finally the jumping, I want it to be able to hop or jump, and so the key is going to be W up arrow or the space bar. And then for testing purposes, since my cloud isn't made yet, that's stage 3, to simulate the cloud hitting, I'd like to test that out. So all I've done here is capture the letter H, and I'm going to use a method called hit in the chick class. to tell it to deduct 10 points from its life. And then for testing purposes, I'd like to show for all of these keys what key was pressed. And just for fun, if you don't want it to make noise, you can just comment that out. Otherwise, if you want to hear it get hit, we're going to play the squish sound. So that's what's going on with the key listener. Then let me explain a little bit. First time you've seen this, maybe, I don't know, the double buffering. So what we're going to do is we're going to get write these things off screen with the create image. We're going to get the same size as the screen, and from that object we're going to get the graphic object, and this has all of the tools we need to change it, to draw images to it, fill it up with colors or shapes. Also, one other part for Windows machines for the double buffering, so to get rid of the flickering effect, is to make a simple little update class that calls the paint method. And then let's open up the paint method. This looks intimidating at first, but it's really quite logical. First off, notice that I'm not drawing to the screen directly with G. Instead, I'm drawing to my off-screen image, which I can control using the graphics object G2 that we just initialized. So we're going to draw the image of the sky. We're going to tell the chick to draw itself, so my chick class is going to have to know how to draw itself, but it has to know where it has to be drawn. And then we're going to draw the cloud, and here the draw image here with the cloud is just so I can scale it. I'll explain this a little bit more in the chick class. And then the messages and the information about the chick. For testing purposes, I'm actually calling all the accessor methods in the chick class and putting them on the screen. So that's all that's going here. And then finally, in line 69, I am actually switching at this point in line 69, and I'm actually telling the graphics, the screen G is going to get whatever I've formed on my my off-screen image. And in order for it to look like it's animated, it's going, and every time things change, we want to redraw the whole screen, and so we're going to force that by disposing of the graphics that we just put the screen and redrawing it, and this gives as fast a possible thing. Now later on you probably want to have more control. You might have to put in some sort of timer or pulse an image that will get attention back. As it is now, this is a simple way of doing it, but it's at the mercy of the system. So if you'll notice that if we play the game a lot and something's going on in the background of your computer, it might lose focus, and it might have these nice smooth falling objects that work most of the time suddenly get interrupted when your computer's busy doing something else. So this isn't ideal, but it is a good simple way of starting out. We can add a timer class if you want to force it to be more smooth. So let's take a look at the chick class. I've collapsed all of these methods just so we can get an overview. We need to, I have a few things on here so that I can easily change. The arena size is horizontally 0 to 800. The size of the chick I might want to manipulate, but right now it's just fixed at a width of 60 and a height of 80. The image, of course, is the place that that holds the actual graphic object that we loaded. The rectangle is the location box. So in one variable, a rectangle variable, an instance of a rectangle class actually, we get lots of nice methods like intersection, and as well as the width, the height, and the top left corner XY value. So rather than having all different values for that, I just have one value called box. Maybe a location would be a better name. And then of course we need to know the bottom. Here I made it a variable rather than fixed, thinking ahead maybe for some later incarnation where it might have a platform it's sitting on. And of course we need to keep track of how much life we have, because eventually we'll die. And then the change in x, change in y has to do with every time that the object moves, we have to know how much. And because the drawing, I'd like to do a mirror image so that the chick is looking in the direction that it's going, either left or right. I keep track of that and whether or not it's jumping. So let's the accessor methods are right down here, line 76 to line 82. Very boring stuff that just reports to things outside the class of the values. And then the interesting thing is, perhaps let's take a look at the constructor. We take in our image and we set the location based and put that in our box. We make sure that we're not moving at all by putting zeros for our delta x and delta y. We figure out the bottom where we are, and we say that we're going to start facing right and we're not jumping, and we start with 100 of life. The drawing, I'll explain the draw image here. First off, we don't want to draw it at all if we're dead, so first test, see whether or not we got any life left. And if we're out of life, we're just going to get right out of the draw method and not draw anything. Otherwise, we're going to move. So let's move our chick, and that's based upon our delta x, delta y. So if we'll take a look at our move class down here, we're going to update based upon our change in x and change in y. Here we have to subtract because vertically speaking, on the screen coordinates, the smaller values are at the top and the larger values are at the bottom. That's why we're subtracting there. And of course we check for limits, make sure we're not off the edges, or light on the top or on the right or left. And then finally, if we're jumping, we have to eventually test to see when we're at the bottom. So if we're at the bottom, we're going to have to say, no, stop jumping. We're at the bottom, so we turn that off. Otherwise, we want to decrease our value. So we start jumping with a large value, which will be positive, so it goes up. But then if we subtract a little bit each time, eventually goes up less and less and less, and then gets to 0, and then it starts falling. And this simulates gravity. This is a very primitive physics engine, they call them, that simulates how if you start at one rate and the rate changes and starts coming back down, rather than adding the gravitational constant. We're not getting that complicated. We're just going to go down by 10%. Anyhow, let's close up the move method and finish up the draw. Last thing I want to explain is the draw image. There's lots of ways of drawing images. This is the one where we can actually have a mirror image, so we can have just one graphic object that's loaded into memory and show it in different ways to simulate facing left and facing right. So I've broken up these 7 parameters. 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters. A lot of parameters. So of course we need to know what image to draw. The top left corner, which is the top left corner of our chick. Then the coordinate, rather than doing width and height, it actually has to know the coordinate. So I have to add the horizontal location to its width to get that coordinate. And the same thing with the height. Rather than just doing the height, it actually has to know the graphic object. You can scale the size of it by changing this. Finally, it has to know what portions of the image. You can actually only show a small box of the image rather than the entire image. We actually want to do the entire image, so that's why I put from 0, 0 to the width and height of the image. That way the entire image is shown. And this is the observer, which usually you could say this if you've got some image controller. Otherwise you could just put in null. We're not going to be manipulating that too much. So that's the draw image. Anything else worth mentioning? Yeah, a little bit. The hit, that's the method that decreases life. And here just checks to make sure you don't have negative life. And then the rest are just accessor methods. So we're done with stage 2. Make sure you can get that working, and you can have fun by having other letters. Again, you would change that in the class that implements the key listener. And in order to have the key listener work, you have to define 3 things. The key released. In this case, if you forget the key released portion, you press the left button once and let go, and it keeps going left. So eventually you have to turn off going to the left if the key is lifted. So that's what this is here. Checking for all of the left and right keys and setting the horizontal change to 0. Okay, now I think I have it all figured out. So have fun manipulating this one. This one here, finally we have something to play with, and it's a little interactive. And this is a good stage to start thinking more about the complexities of your game. Next is stage 3, where we're actually going to have, rather than have a fixed cloud, we're going to have a bunch of clouds floating on the top and having them fall from the sky. So I'll see you then.